Alrighty, Chem 20s. Today we are talking about how to make solutions and how to dilute solutions. So unfortunately this year we won't be doing the cool labs of actually making solutions from solute, but you can certainly read this notes guide and also your textbook. And these pages are in your textbook 215 to 219. So one way scientists make a solution is from a solid solute. So this is just like if you're making Kool-Aid or iced tea, right? You have the solid and you put it in some water, you add some water, the solvent, and that's going to dissolve the solute, the solid. Another way of doing it is scientists have stock solutions, and they're very highly concentrated solutions, and they need to dilute them, right? They don't need the very high concentration. They need a more dilute concentration. So you guys have maybe done this before too. If you take a frozen concentrate, like that frozen can of orange juice, and it's a really high concentration, but then you add a whole bunch of water to it, you're watering it down, right? That's what it means to dilute it. So you can read through standard solution and the different laboratory equipment you would use if you were actually making the solution. And in fact, you can also read through the procedure, although unfortunately, like I said, we're not going to be doing a lab this year. So here's a practice problem I want to work you guys through. And we've already done some like this when we did our concentration of ions notes guide, right? And so we're asked to make a solution, and they're wondering what mass of the solute are we going to use. So let's read through and see what all information they've given us. So we have 100 mils, and so that's a volume. So I'm going to write down my volume. Now, how many sig digs is that? Well, let's see, 1, 2, 3, 4 sig digs. So make sure that when you convert it to liters, you don't just write 0.1. That's not 4 sig digs. You have to make sure that you have all those zeros, right? So now that's 1, 2, 3, 4 sig digs. So that is the volume that we're starting with. And now we have a moles per liter. This is an amount concentration. And so we know that there are 3 sig digs in this. And we're looking for the mass. So mass in grams is what we're trying to find. We actually have one more piece of information. They've given us this chemical formula, ammonium oxalate. So from that, we can use our periodic table and calculate the molar mass. Molar mass is always a conversion factor. So we are looking for the mass that we need. We have a volume and a concentration. So what do we do next? Okay, well, we've got our information written down. So let's begin with the volume. How will I cancel out volume? Well, I see liters is on top. So if I have liters on top, well, I'm going to want to put liters on the bottom to cancel it out. So which of these terms has liters on the bottom? Well, this guy, concentration. So that's going to be my next step. I'm going to multiply the liters, the volume, by the concentration. And there you go. I'm going to cancel out liters. So now what units do I have? Well, now I have moles. So now that I have moles here, I would like to cancel it out, right? I'm looking for mass in grams. So here is our unit conversion. Our molar mass we're going to use, and we're going to put grams on top, moles on bottom, so we can cancel it out. And so it's going to look something like this. So moles on top, moles on bottom cancel out, and what are we left with? The grams, and that's what we're looking for. We're looking for a mass in grams. Okay, so just punch those values into your calculator. 0.1 times 0.250 times the molar mass, and what do you get? Well, you get, and I've rounded this, and I put 3 significant digits, and I have my units. My units are mass in grams, and I have my entity, my compound that I was trying to find. So always for your final answer, you check your number of sig digs. You may have to round to get that answer. Make sure you have correct units, all right? We always are using grams for mass. And then make sure you also have the entity. What is the thing that we're finding the mass of? Okay, so there you go. That's how you work out a question like that for full marks. So you can do a bit of practice. You don't have to do every single question in this booklet. Maybe just do the odds, okay, or do them all, whatever feels comfortable for you. There's some more at the end of this booklet as well that you can get some extra practice in. Okay, so that is how we make a solution from a solute, from a solid. What about if I have a big jug of a really highly concentrated solution, a stock solution? How would I make a solution? Well, I would dilute my very concentrated stock solution. So the formula that you have in your data booklet, now some people like to write it CIVI is equal to CFVF. I like writing C1 V1 is C2 V2. That reminds me a lot of our Boyle's Law formula, this inverse relationship, okay? And so whichever way you want to do it, it's fine. I accept either one. So Ci is the initial or the starting or the first concentration. So that's why we say C1. And of course, its units are in moles per liter. This is our stock solution, our really highly concentrated solution. And some of them are like super high, like 17 moles per liter, right? Like a really highly concentrated solution. Vi, initial or starting or first volume, the units for that are liters. So if you have a milliliters and you're asked to find in liters, then you have to do a unit conversion. So this is typically a small volume. You don't need very much of this really highly concentrated stock solution, and you're going to dilute the solution. So CF, the final, the second, the ending concentration, it will be diluted. It's going to have a smaller number. It'll be a lower concentration because we're adding water to it, right? We're diluting it. And then the final volume, well, that's going to go up. So as I mentioned, the initial concentration is very high, and we only need a small amount of volume. And now my final concentration is going to be very low. I've diluted it, and my volume is going to be much larger. And so these two numbers multiplied together will equal these two numbers, right? They're constant. So an example question that we might have here, well, this is just a communication example, and I like to really read through here and decide what's my initial, what's my final. So I'm adding water to this number of liters. That's the initial, what I'm starting with. And this is my initial concentration. That's the highly concentrated stock solution. And so they're asking me to find the amount concentration. That just simply means I have to find a volume in moles per liter of the diluted solution. Okay, so they're looking for C2. And they're telling me also the final volume, V2. So we write out the formula, we rearrange and solve for CF or C2 and plug our numbers in, and then we can see that we can do some canceling. Liters cancels. What are we left with? Moles per liter. So is that a value for a concentration? Absolutely. And ask yourself, does it make sense, right? Here's my initial high concentration, 2.4 moles per liter. I've diluted it. Well, yes, I have, because that concentration is lower. So by all means, check your work, right? Ask yourself, does it make sense? Okay, so always check your answer. Does it make sense? If I have a high number for my concentration, so like in that example, it was like 2.40, then my final concentration should be a smaller number. And it was like 0.480. Okay, so that should make sense. Always check your answer, check your units, check your sig digs, and make sure that you are doing all your steps showing your work. So here's another example I have for us here. So we're looking for the volume of this really concentrated stock solution. Look at that, guys, 17.8 moles per liter. That's a huge number. We know from here the volume. Here's how much we're making of our dilute. So we're making 2 liters. That's a large volume. But now we have this lower concentration. Why? Because we're diluting it, right? And so we're taking our concentrated solution and we're adding water to make it less concentrated, more dilute. So what do? Well, we write our formula down. C1V1 is C2V2. And what are we solving for? Well, we're trying to solve for V1. So that means that we have to rearrange. That means I have to get rid of C1 off this side of the equation, cancel it out. And what am I left with? Well, I'll be left with V1 is equal to C2V2 divided by C1. Okay, great. Now I plug my numbers in. And let's see, is there anything I can cancel? Oh, look, here's the same unit on the top and the bottom. I've got moles per liter here, moles per liter here. It's going to cancel, and I'm going to get liters. Is that a volume? It sure is. That's a unit for volume. Okay, great. So now I punch out that math on my calculator. What do I get? My final answer, 0.0225 liters, or if I want to convert that to mils, is 22.5 mils. So again, I have a small volume that I'm starting with. I'm starting with 22.5 mils to make how much? To make 2 liters, a much higher volume of my solution. Okay, so I've diluted it. I took this stock, highly concentrated solution, and I made it less concentrated. Okay, so some practice questions for you guys to do in this booklet. You can read through the procedure here, but honestly, we're not doing this year. You can watch the video if you want. And then here's some more extra practice. Maybe do odd numbers, or maybe just do a few more questions until you're feeling confident in it. You will see this on the formative this week, so please make sure you are doing some practice. Answer keys will be posted. If you have questions, you're always welcome to email me. And I guess that's it for now. Talk to you later.